Okay, I didn't get to lesson 22, so I'm going to do a quick lesson on 22. And I do things differently than the book, so it would be really helpful if you watch it, because the way I do it is a lot easier than what the book does. I don't know if you can read that, but it says Lesson 22, Absolute Value and Reciprocal Functions. So, we should know this. We've done absolute value since you were probably in 6th grade. But the absolute value of a number can be defined to be the distance along the x-axis from the origin to the graph of the number. So, for example, the absolute value of -3 is 3. Absolute value is distance. So it's always going to be a positive number. That's why the absolute value of -3, so if we put -3 on our little number line here, and you said what's the distance from -3 to the origin, the distance is going to be 3. That's the distance. It's always positive. Now in this lesson we're going to do absolute value inequalities. So they want to know what numbers, absolute value of what numbers are greater than 3. Or we can say what numbers are more than 3 from the origin. So I'm going to do this one in red. So if the numbers are going to be more or equal to 3 from the origin, here's the origin, so we would go 3. And we want all the numbers that are more than 3 units away from the origin. So it would be all these numbers. And then it would be -3, because that's 3. This is 3 from the origin, right? And greater than 3 distance. So like if we have -5, -5 is more than 3 units from the origin. Now when we're talking about the less than, we want all the values of x that are less than 3 units away from the origin. Well, so 3 is less than or equal to 3 units away from the origin, and +3. And all the numbers in between are less than 3 units away from the origin. Okay, of course those were super easy. The book does some really weird method of doing this problem, but I'm going to show you the easiest way to do these problems. Here's the first one. The first thing you do is you want to isolate the radical. So we're going to add 2 to both sides. So we'd say the absolute value of x is less than 2. And if it's less than 2, we want all the values that, if it's going to be less than, we're going to be filling in between the dots. So we're going to get our -2, here's our 0, here's our 2. This is open circle because it's not including 2, so we just make it open circle, and we're going to fill in everything that's less than 2 from 0 on the origin. The other way you can do this is you can say x is less than 2 and x is greater than -2. So you're just going to you're going to free it by putting x is less than 2, and then you flip it around and change it to negative, and you say x is greater than -2. So that's what we have. It's greater than -2 and it's less than 2, and this is where they overlap. These are all the values that make this true. Okay, let's try this one down here. This one is the absolute, this is just how they're going to write it. X is an element of the real numbers such that the absolute value of x minus 5 is less than 2. So we're going to do it like I set it up right here. We're just going to say what's inside of there is less than 2, and what's inside of there is greater than -2. So you just flip your inequality sign for the second one and change your sign. Because if what's inside of here is, well, let's just do it like that. I'm not going to explain it. So we're going to solve each of these. So we get x is less than 7, x is greater than 3. So I just added 5 to both sides, so we get our numbers. So we're going to have, and this is less than, that means we're going to be filling in between the circles. So here we have our 7 and our 3. 0 is going to be closer there than that one. So x is less than 7, so open circle on 7, open circle on 3, less than 7, greater than 3. I used to teach this differently, but I think this way is the most consistent way to do it. So you just set what's equal to there, you just set what's inside of here less than, just exactly like it's here, and then you flip your inequality signs and change your sign and solve, and that's your other equation. Okay, let's let's look at one more of these. I don't think they're that complicated. So this one's the same thing. We're going to say this is greater than, so if it's greater than, it's going to be going this way and this way. So we take exactly what's inside of there and say it's greater than or equal to 3, and then we take exactly what's inside of there. We flip the inequality sign, and we also change this sign, and you solve them, so you get x is greater than 1 and x is less than or equal to, whoops, I forgot to end this, negative 5. So we put our numbers on here. We have our negative 5 and our 0 and our 1. So it's greater than or equal to 1. So we fill in the 1. It's greater than 1. That's that. And it's less than or equal to negative 5. So you're going to see these on the SATs. You probably already did see them. But you just set them up to two separate equations, because you can have what's inside of here is greater than 3 and the negative of what's inside of here is greater than 3. So you should have two. Absolute value always has two answers. Okay, we're going to hit on graphing. I'd like you to try to use your graphing calculators if you can to do these, but you also need to know how to plot points. So I want you to plot the points and graph it by hand and then check it with your calculator. This is a graph of an absolute value. You're always going to have a positive number when you have, if we don't have anything added or subtracted on the end of these. Absolute values always look like these. They're always going to look like these, so keep that in mind, because whatever we put in here, positive or negative, we're going to get a positive answer out, because absolute value is always positive. So we're just going to pick a couple random points for this one. These are really easy. So if we put a 0 in, we get a 0 out. If we put a 1 in, we get a 1 out. If we put a negative 1 in, we get a negative 1, etc., etc. These are super easy. And then you just plot the points. So we have 0, 0. I should use something a little darker. 0, 0, 1, 1, 2, 2. See, we're getting the V. Negative 1, 1, negative 2, 2. And we would just get lines straight up. So we can just connect all these. And that's how you graph an absolute value. Now later we're going to have things like plus 5. So this whole graph is just going to move up 5, or minus 2, the whole graph will move down 2. And we can always also move it left and right. Here, just to get an idea, we need the absolute value is always going to be a V shape. Okay, some more complicated things coming up. I can move my little screen. Okay, we're going to be graphing a reciprocal function. Somehow or other. Okay, if the original function is y equals x, the reciprocal function is y equals 1 over x. Because reciprocal means inverted or upside down. The graph of a reciprocal function has a vertical asymptote. They just throw this word in here like we've used it 100,000 times, but I don't remember using it. Maybe we did at the end of Algebra 2. It says the graph of the reciprocal has a vertical asymptote at every place where the graph of the original function intersects the x-axis. What an asymptote is it's a line, and if it's vertical, it's going to be a vertical line like this. Okay? It's a line where the graph doesn't touch at all. And it's going to help us when we start graphing these more complicated things if we can identify where the asymptotes are. Now this one, the lesson today, we're only going to do vertical asymptotes, and we're going to just barely touch on it. So if I would graph this line y equals x, that's just a straight line. And if we can just put our points in here if we wanted to really quickly, whoops, that was really bad. Really quickly put some points in. If we have 0, 0, 1, 1, see how it's just going to mirror each other. So let's put those in. So we get 0, 0, 1, 1, negative 1, negative 1. And then we can draw ourselves a straight line, and you can see what the straight line is going to look like that. The vertical, to graph its inverse, the asymptote is going to be where the graph crosses the x-axis. So our asymptote is going to be, it crosses the x-axis right here, crosses it right here is where it's going to cross the x-axis, right? So the vertical asymptote is going to go through that point right there. So let me just draw in a vertical asymptote. Patience, please. This lesson. I know I lose probably most of the class when I do this. You just don't feel like watching such a long video. It's time to go fast. Okay, our graph of our inverse is not going to touch this line. So our graph is going to be over here somewhere, over here somewhere. We're not sure until we plot a couple points. So we need to plot some points in the positive direction, some points in the negative direction, and try to figure out possibly what this graph is going to look like. So let's just start. I put some numbers over here. If we put a 2 in, we get a 1/2 out. Let's do that. Another crazy color. Okay, we're going to get 1/2 out. If we put in a 1, we're going to get a 1 out. If we put in a 1/2, we're going to get a 2 out. If we put in a negative 1/2, we're going to get a negative 2 out. If we put in a negative 1, we get a negative 1 out. And if we put a negative 2 in, we're going to get a negative 1/2, or negative 0.5. Okay, hopefully this is enough to show you. The asymptote, what's going to happen is the graph always approaches the asymptote. It's going to get closer and closer and closer to it, but it will never touch it. So let's just see what these points look like. 2, 1/2. 1, 1. 0.5, 2. Now what's going to happen is if I pick a number like 0.8, it's going to give us something, it's going to give us a bigger number. Our numbers are going to keep, as we get closer and closer to 0, we're going to get bigger and bigger numbers. And if I put in, like, say I put in a 3, I'm going to get 1/3. It's going to get smaller and smaller, but it's never going to cross. There's no way we're going to get y to equal 0, because you can't have a 0 in your denominator, so x is never going to hit 0. So our graph on this side is going to look like this. I'm really bad freehanding with this tool I have. That shouldn't have touched the y-axis. It's not going to touch it. It's going to keep approaching. The same with the x-axis. It's going to keep approaching, but you can see x can never be 0, because if x were 0, it would be undefined. Okay, let's do these real quick. So we get negative 0.5. We're going to get negative 2 right here. We're going to get negative 1, negative 1. It's right here. And 2, negative 1/2. Same thing's going to happen. We can't cross this axis, because if it's 0, if x ever is 0, this is undefined. So it's going to keep approaching through infinity. It's never going to touch that line. And the same with your vertical asymptote. It's never going to touch this line. It's going to get closer and closer and closer. It's never going to touch it. So this is what the inverse function of y equals x looks like. The vertical asymptote is where that function crosses the x-axis, and we can see they haven't brought this in yet, but this is called the horizontal asymptote because x can never equal 0, so the graph is never going to be able to touch 0. Okay, we're going to try one more. They want us to sketch this graph, y equals 1 over x squared. Whoops, hold on a second. Okay, this one, you can see again, look what's going to happen. This can never equal 0, so it's never going to cross the x-axis. So we can even put a horizontal asymptote in there. It's never going to touch this. You see that? And if you would graph the reciprocal function of this one, you would have y equals x squared, right? And it would be a parabola. It would be a parabola hitting 0, 0. So this is going to be our vertical asymptote, where that graph hits the x-axis at 0, 0. So we just need to plot some points and see what this thing's going to look like. So I put some points over here. You'll notice that there's no way that y is ever going to be 0. You need to make some observations when you do these and think. Just think about it. There's no way y will ever be 0 because whatever we put in here we're going to square. So all our numbers are going to end up being in these two quadrants. So if I put a negative 2 in there, I'm going to get 1 over 2 squared, or 1/4, which is 0.25. They're always going to be positive here. Oops, let me just do a better color too. So we're going to get 0.25. If I put a negative 1 in, I'm going to get 1 out. If I put a negative 0.5 in, I'm going to get 4, half squared, and then I'm going to flip it and get 4. This is also going to be 4, 1, 1, 0.25, again. And then we're just going to plot these points, and it's not ever going to touch, but it's going to approach your asymptotes. It's going to get really, really close to both of these. So this one's going to look like negative 2.25, negative 1, 1, and negative 0.5, 4. 1, 2, 3, 4. And it's going to be mirrored on the other side, as you can see by the points that we plotted. And when we connect them, they're going to approach your asymptotes, but they're never going to touch them. Because x can, ooh, that didn't really approach, did it? Sorry, this isn't going to quite be right. I can barely get my pencil to do anything I want on this thing. And the same over here. Just going to come down here. It's never going to touch your axes. Because it can never, this will never be negative. It's never going to get on there. And we also know that there's no way that we can get a 0 for y, because 1 over 0 is undefined. You can't get a 0. And you can't have a 0 in the denominator, so it can't go that way. Alright, so it's probably good to do this lesson with this because I had graphs to use here. Hopefully that helps. Check them on your graphing calculator, but don't overuse your graphing calculator. You need to be able to do these points. Alright, that's it for lesson 22.